Today we'll be factoring special patterns, and our objective is that we will be able to factor special square and cube patterns. So let's start with our special patterns for squares. You can only factor the difference of two perfect squares. So if we have a squared minus b squared, that factors to a minus b times a plus b. If we're trying to factor a squared plus b squared, that's prime, meaning it can't be factored. So if we have 4x squared minus 121y squared, those are both terms that are squared. If you notice in our pattern, we start with a squared, but we need to get to just a. Basically, we need to square root each part of the term to figure out what our a is for our pattern. So if a squared is 4x squared, then a would be 2x. If b squared is 121y squared, we take the square root, b would be 11y. Therefore, our factors are 2x minus 11y and 2x plus 11y. Here we have x to the 8th, which you may not realize is a perfect square because it's x to the 4th times x to the 4th. So that means our a term would be x to the 4th, and our b term would be the square root of 256, which happens to be 16. So our factors would be x to the 4th minus 16 and x to the 4th plus 16. But wait, x to the 4th is a perfect square because x squared times x squared equals x to the 4th. So we could factor this parentheses again, and a would be x squared and b would be 4 this time. So we'd have x squared minus 4, x squared plus 4, and then we're going to bring down our x to the 4th plus 16. But wait, x squared minus 4, that's another difference of perfect cubes. A would be x and b would be 2 this time. So we'd have x minus 2 times x plus 2 times x squared plus 4 times x squared plus 16. Now we're finally done because we have no more difference of perfect squares. All right, so we have 75m squared minus 243. Those aren't perfect squares, but what you may or may not know is that they're both divisible by 3. So that means they have a common factor. So I'm going to start by dividing by 3 first. And I'm left with 25m squared minus 81. Now I do have two perfect squares. My a term would be 5m and my b term would be 9. So my factor would be 5m minus 9 and 5m plus 9. Don't forget to bring down your GCF. Finally, we have 25z squared plus 9. These are two perfect squares, but look, it's not a difference this time, it's a sum. that means this is prime. It can't be factored. Now let's look at the special patterns for cubes. They're very similar, whether we have the sum or the difference. They both can be factored this time. The pattern for if we have a cubed plus b cubed is a plus b times a squared minus ab plus b squared. The pattern for if we have a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So the patterns are almost identical except for the signs in the first parentheses and the first sign in the second parentheses. The first sign always matches the sign that we were given in the problem. The second sign is opposite of what we were given. The third one's always going to be plus. So again, same as what we had, opposite of what we had, always plus. So let's look at an example. We have 8w cubed. So that's what our a cubed is, which means 2w would be our a, because 2 cubed gives us 8. 2 to the third would give us, w to the third gives us w cubed. Our b would be 3, because 3 cubed is 27. So let's follow our pattern. We'd have 2w plus 3 times 2w squared minus 2w times 3 plus 3 squared. So now we've got a lot going on in this second parentheses. Let's simplify. Keep our first parenthesis the same. Here, 2 squared would be 4. W squared is w squared. Minus 2w times 3 is 6w. And 3 squared is 9. Let's try another one. Uh-oh. 2 and 250 are not perfect cubes, but they can both be divided by 2, so we need to factor that out first. So 2 times z cubed minus 125 q cubed. That makes things a little easier. That means our a term would be z, and our b term would be 5 cubed. So I would have z minus 5q, z squared plus z times 5q plus 5q squared. Don't forget to bring down your GCF. Bring it down again. Our first parenthesis, there's nothing to simplify. In our second parenthesis, we'll keep the z squared, then plus, we have z times 5q. We're going to write 5zq. The order you write the letters doesn't really matter. Usually we do alphabetical order. I'm just doing it in the same order that they were in the parentheses. Plus 5 squared is 25, and q squared. That's all for today. See you in class.